You got no replies or likes.
Oh, no. People like that one. Because, you know why? It's funny. I got some loves, I got some ha-has, I got some likes, okay?
But no one dignified it with a response.
Oh, maybe. I think someone was like, that's further than that. I don't remember every interaction ever.
You
But I
should
do
have
remember-
it last week, dude.
No, last year.
Yeah.
I heard last week.
Oh, I didn't mean that. If I said that, it was a mistake.
5 seconds.
Okay, so my name is
Mr. Castle.
Mr. Costo. Me llamo
Mr. Castle.
Senor Costo.
No.
No, sir.
Senorita Castle.
S-I-R Castle.
Okay, transformations. Transformation is an operation that maps an original figure called the pre-image. It maps the original figure, which is called the pre-image, onto a new figure called the image. So you have a pre-image, you have an image. The pre-image is how it starts, it's the original. Then we map it to a new figure called a image after we change something to it. Yes, Taylor.
I just want to point out we didn't see your fun socks last year.
Okay, I'll show you guys later. A transformation can change the size, position,
Right, a little bit bigger.
or orientation
Don't you have glasses?
of a figure.
Oh. Yes, no.
That says positive.
I spelled it right the first time. Botch. Double botch. Ooh, I spelled it right, looked at it, that's not right, changed it, made it wrong. Should have trusted my gut. I always say
That one time
never
you
ask
spelled-
you.
you spelled like airplane or something
Okay.
on that one day.
So a transformation changes the size, position, or orientation of a figure, okay? First kind of transformation we're going to learn is a reflection.
It was
Reflection is a flip over a line called the line of reflection, called the line of reflection. Very original, right? It's flipped over a line called a line of reflection. Reflection's over a line called a line of reflection. Very
As
original.
creative as you are.
It's true. Okay. Each point and its image, each point and the overall image are the same distance from the line of reflection as they were before. So we have three possible lines of reflection, three different types of lines of reflection. We have the x-axis or y-axis, so either of the axes. We have vertical or horizontal lines in the form of x is equal to a number, or y is equal to a number. Those that had me for Algebra 1, you should remember Hoy Bucks. There you go. Hoy Bucks is horizontal lines have a slope of 0, and it's y equals a number. Bucks is vertical lines have an undefined slope, and it's x equals a number.
That actually helps.
Wait,
What does boy mean?
Horizontal lines have a slope of 0, and it's y equals a number. The equation is. Then we have diagonal lines in the form of y equals x, or y equals negative x. We know this is our identity function, and then the y equals negative x is just the negative of it.
That could give me a lot of stuff to remember, and I just don't remember any of it.
Okay, didn't you say like one day you were gonna give us a list of jobs that use geometry and algebra?
Found algebra once.
I don't know what you're pointing at.
The sign that says, when am I ever going to use
Okay,
geometry? Has
what about
lots of jobs.
Algebra's right
What
there.
over there?
Okay, calculus.
That's Mr. Titus.
You're gonna use that if you're going to be like an accounting or something. Calculating.
Continuing on, right below this. We're going to practice this. We're going to practice this. We're going to practice. We're going to practice. Okay? So, triangle ABC with vertices A, B, and C. And we're going to reflect it over the x-axis. Okay? So, what we're going to first do is we're going to graph and label the pre-image. We're going to graph and label the pre-image, so the points that are given to us. So, -4, 2. Which way do we go -4? Left. First number is x. So 1, 2, 3, 4. What direction am I going to? So that's point A. Okay? Who wants to pass out rulers?
Nope.
Sarah, okay, thank you. You can pass out the rulers next to Rowan and the phone there.
Ruler is math class, not whatever we're about to do.
This is math.
No, it's not.
I'm
It's
sorry,
really
art
like
class.
math English.
No.
Yes.
It's just for a straight edge.
Exactly.
I can use my paper for that.
Okay? B. 4, 7. So we go 4 to the right. 2, 3, 4. I didn't copy very well. And 7 up.
Hold up.
7 up.
Yeah. Oh, just kidding. I was wrong.
Okay. Then C is going 5 over and 1 up.
Why are you like really
Really what?
mean?
Oh, because my job is to make you cry.
That's not in the job description.
You keep saying that, but you haven't read it.
I want a
One of us has read this and one of us has
I
not.
want a copy.
Okay, look online.
Sorry.
What? For classmates?
Yes.
I don't think they show
Okay,
that.
so then we can connect these with a straight edge.
Or we could like not.
Or you could. Which is why you have a ruler. Oops. So how you use a straight edge, in case you don't know, you line it up, then you go. Okay? That one didn't work
That
very
is
well.
not a straight edge. A straight edge is a tool. That's a ruler.
Okay, you can use anything as a straight edge, so anything that's straight.
Wait, we
Ah.
need triangles now? No.
Okay, so we have triangle ABC. And we're going to try and reflect this over the x-axis. Which is the x-axis? Show me with your hands.
Bro, it's
Very
that
good, this way. The x-axis goes this way, okay? So if we're reflecting it over this axis, what are we going to do with this image? Is it going to go this way or this way? It's going to go this way, okay? I want everybody looking up right now, everybody looking at me. Have your hands out in front of you and do this with me. Very good. Reflecting with the x-axis will go this way, okay? So we're going to reflect everything over this way. So it's like you're going to take this, it's like you're going to copy it, you're just going to flip it over, okay? So how far is C from the x-axis? 1. So how far is it going to be from the x-axis on the other side? 1. And it's going to be in the same position as far as left to right, because we're just reflecting it over the axis. We're not moving it left to right at all. We're just flipping it over, okay? So that's still going to be C. And we're going to call that C prime, okay? And you're going to have a little apostrophe there, okay? That's just telling us it's our new C, okay? We're just saying, hey, this is the C that we transformed. Yes, Peyton?
Did you put it in the C thing?
Okay, we will do that in a moment.
How come your graph looks funky?
Okay, yeah, I kind of copied weird. I don't know why. Okay, so B, how far is B away from our x-axis?
4, -7.
It's at 7 originally, so it's going to be 7 down. That'll be B
Oh,
prime.
we're not writing.
Okay. And how far was A away from the x-axis? 1, 2. So how far is it going to be from the x-axis down? 2. It's going to be A prime. Now we can connect these points.
Wait, but what would you do if you had to flip something, but it was on both sides?
We'll talk about that. Actually, I don't think we'll talk about that.
Wait,
So let's talk about that now.
are we gonna talk about
We can talk about it.
like what if it's like on the line?
We'll talk about that too. We'll talk about what we do. It'll make more sense in a few moments. After we see a few more, okay? So, and does this look like it was just flipped over the x-axis? If you just kind of did this and just went, whoop,
Yes.
whoop. Okay, it does. So let's figure out what our points are, coordinates. So A, what is our new coordinate? -4, -2. What's our new coordinate for B? 4, -7. And what's our new coordinate for C? 5, -1. Hey, did we notice anything about these compared to our original?
Yeah, no,
It's just like this. The
Ryan is switched.
The y is negative. The x is the same, the y is now negative, okay? Well, that's because if we just flip it over the y-axis, it's still going to be the same distance. Because isn't this the y value, isn't that really just how far away it is from the y-axis?
Sure.
Because that means it's 2 away from the x-axis. It's 2 up. It's 2 away from the x-axis. This is 7 away. This is 1 away. They're just in a positive direction. So now we're going this far away in the negative direction. Hey, you should stand in the corner.
No.
You want me to do this again?
I can do this all day. Okay.
Wait,
So-
why is she in the corner?
She was
Stop.
cold.
Literally cold.
Hey,
She was cold, so I'm telling her to stand in the corner because
It's 90 degrees.
90 degrees. Yeah, I got a few smiles there. Got a couple eye rolls too, which is perfect, honestly. It's like a great combination, okay?
I'm
So,
happy, Rachel.
we're noticing here that, hey,
It is so cold.
we have a rule here where we have x comma y yielded. You've had x and y, and we yield. We get from this. Okay, yield means you get from it. Okay, you yield x comma negative y. So we took all of our original x, y, and we made it x comma negative y. X, y became x comma negative y. X, y became x comma negative y. So if you flip over the x-axis, it becomes x comma negative y. I suggest you write that down there. Okay? I suggest that you write x-axis gives us the x comma negative y, and write it like this. X comma y, the arrow, x comma negative y. We'll be using that throughout this chapter quite a bit, that notation.
Can it be the opposite as well? Like when you go from X.
Like going here to here? No, we always start out with x comma y, because we start out with the normal. So we say, hey, from a normal point, x comma y, saying x can be negative, y can be negative. Our new one will be the negative version of the y. Okay. Talk. Okay? Okay. So, let's look at number 2. Rectangle PQRS with vertices P, Q, R, and S in the y-axis. Are you warmed up now? Oh, okay.
Rachel, Mr. Fossil,
Yeah.
can we know?
Do you want to try doing it by yourself?
Yes.
What's it reflecting over? The
Why?
y-axis. Okay, go try it by yourself.
But
I did it.
you're more country than Mr. Gossip.
That's not true.
Points to done.
At least people laugh at your jokes.
You want to object?
I don't want to. Bro, that's me walking out of the field for marching season. That was funny. So very funny.
Yes,
You didn't
I
even
laughed
see
really
it.
hard.
It was funny.
You're like actually the most funny
You're
person I've heard all day.
Good.
Genuinely,
Crazy.
some guy rolling
That's what
on
it
the floor.
Mr. Acosta, please tell me what this says. Your butt every single way.
You're beautiful in every single way, although it's saying the wrong number.
Where do you see beautiful on there?
Well, it's spelled wrong too.
Yeah, B-U-T-R.
Someone really sucks at English. That's
James, are you warm?
I was pretty hot with my sweater.
Did you cut that shirt?
They see the seams on it.
James is trying to flush.
Sorry, I can't. It's like your muscle tee.
You see,
That was so awkward. That's
it's very scary.
Okay. Oh, James,
That's what I did yesterday from
Scary
coloring.
sight to see.
Wait,
Look
at the same way.
How'd you do that?
We were coloring the Monsters vs. Aliens sign or whatever,
Y-axis.
and I got purple on the wing. I smudged them. I would like smudge the whole thing. So if you see the Monsters vs. Aliens signs on Halloween, I did that.
What a terrible person.
Have them car for golf. Why am I involved in things? Like it's kind of annoying.
I have 2.
Preach.
And I gave birth to double twins. Obviously.
Hey, if you're at home, by the way, and you don't have a ruler to use the straight edge, what else can you
A
use?
piece of
Paper.
Piece of paper, a book,
You're
phone, okay, lots of stuff.
What if I don't use a straight edge?
Yeah.
Rebel.
Yeah, I don't use a straight edge. My lines were pretty
Rebel.
fine.
Just like more than
This one's just made in China. What am I just moving from?
good enough.
One of mine is
That's how you grade a test too. Look.
Yep,
Oh, USA.
Wait,
good enough to move on.
Okay,
Get
if I tape this to the end of my ruler.
but got it.
Which axis are you Be ready for this x-axis though.
How did you tell me that that was okay, but I did it horribly wrong?
You said that was
Yeah.
made out of meth.
Oh yeah, you did too.
What did you do?
I flipped it over the x-axis.
So did I.
I just wanted to see if you would do it. You noticed it.
Very good.
You got her. You got her.
My birthday was all the same.
Yeah, that's not good.
Mine's like triangles and rounds.
That's good enough to fail.
They're all above our shoe.
This one looks curved.
Oh.
Like yours looks so much
Shoe?
better than mine do. Mine like looks weird.
Oh, now you did
I
that.
think that's because I didn't
No,
go
set
straight.
our coordinates right.
Oh,
Then we take over. Hey, what's the square root of the answer? Square root of the answer. That's what you're saying. Square root of the answer.
Hey, do you want my ruler? I don't use
Okay.
I'm
No.
different.
Is it? Oh,
Yeah.
that was on the wall.
I am. I'm different. Do you want me to also help?
Yeah,
I wonder why you chose that one.
Also, you have to.
Also, what did I do?
Do it
Probably
a little
everything
bit.
wrong.
That's fair.
Yeah, that's good.
Okay. Taylor, why are you trying to press the real one? Pick it up and try again.
Yeah, why do you do
Hey, graded.
No.
Please.
But where's this at? What's the y value?
She's nice. That's not her.
Confused.
Oh.
What's that? What's that? What would you got? Right.
I did it over that house on map.
I know. I
Hey, would you check it this time?
I'm not making any application.
No, I just wanted to.
Alright, you're at the very bottom of my paper.
Square root of the answer is?
Rowan, I didn't lose our streak. We're good.
What?
I didn't lose our streak.
There's still power.
I was back on my streak.
Actually, we lost her like
Yeah.
streak.
So that I am looking all of my streaks because I like end up on parents.
Wait, flip it over the origin? Yeah. That's one of our favorite.
The only streak that I'm keeping is that with them.
You lost her streak?
I lost a lot of mine.
Why?
I have a lot of
Well,
threes.
where's the Bonnie?
Why?
Yeah, I lost a lot of mine
Piece
too.
of luck with that.
Yeah.
We're keeping ours. Actually,
What?
We're keeping ours.
It's at 6.
Okay! Okay!
This Friday, right?
So, if we plot this, 1, 2, T,
Are we going to do all of them?
2.5. Probably not. R, 8, 3, and S, 7, 0.
You should have something fun to do.
Maybe next time. Okay. Then, if we mirror it over the y-axis, which values are changing? Oh, yes! Hands up for the y-axis. Everybody hands up. Everybody hands up. Everybody hands up. Let's go. Wait. We're almost there. Everybody hands up. Everybody hands up.
Taylor.
Everybody hands up. Okay? Then we'll flip it over the y-axis. Everybody do this. Everybody do this. Everybody do this. Taylor, everybody do this. Everybody do this. Come on, Amber. Come on. Yep. Yep. We'll stay here forever. There you go. There we go. Okay. Thank you. So we'll go over this way. So what values are changing? Are the y values changing?
All of them.
No. The
They're off.
x values are changing. What's happening with their x values?
They're going negative.
They're all becoming negative. So this is -1, this is -2, this is -8, and this is -7. Our y values stay the same as they were before. You can just copy them from before. Okay? So I like to go through this when we have just the x-axis or y-axis and we're just making something negative or positive. I like to go through and just do the points first and then go. Okay, I want to show you the first way so we saw what it looked like. Once we get the hang of the one, I have to go through this way, okay? So -1, 2, that's our p prime, okay? Q will be up here, okay? R over here, and then S over here. Sarah, what's your question?
So on number 1, let's say we're flipping it over the y-axis. What would happen?
If you flipped it over the y-axis,
Yeah.
okay? Well, your A, the x of this would become negative, the x of this would become negative, and the x of this would become negative.
So
You
then-
still just follow that same rule.
Okay.
So it'd still go like this. This part would be here, this part would be here. Yep. Okay? So we got from x comma y yields -x comma positive y. That'd be helpful to write that down as well. I almost said write that down instead of write that down.
Write it down.
I'm hunting wabbits.
Are you on your flu shot or flu shot?
You're not supposed to.
Wait, when she
I was supposed to get my
You
flu
show up
shot
at 6.
today, but I can't.
I don't think you're supposed to get Yeah, I don't think you're supposed to get it.
I really hope
I guess
you're not doing
Give me
I
one.
low key probably am. You did spend like 2 nights
Okay.
at my house.
Question number 2.
So.
Okay? Do you guys feel like you have a decent handle on that?
Yeah.
Yeah.
Okay, we'll skip to 3 and 4. Go to the next page. You got it.
That's why you don't work your
Maybe
hands
it's all
out
that
there.
sugar I had.
Oh,
No, it's because I was sick when you were over at my
oh,
Yeah.
Okay, number 5. What are we doing differently this time? Flip it across what?
The line X.
The line x equals 4. So what kind of line is x equals 4? Boy or bucks?
Boy.
Bucks.
Bucks! It has the x in it. So what's it let's start with? Bucks starts with,
V.
so it's a
V.
vertical line. Vertical is going which way?
Up again.
Up and down.
Okay, Riley, you're just telling me up. I see what you're doing. Okay, so let's plot these points. 1 comma negative 1. 2 comma 3. 3 comma negative 2. Okay? So we have J, K, and now let's try not to say that here, please though.
After you laugh, this is not.
Okay.
God.
Yeah, I don't like that word being used in a proper way. Okay. So over the line x equals 4. What I'm going to do here is I'm going to highlight where x equals 4. That's all the points where x is 4. So x is 4 here, and I'm going to do that with a dashed line. A dashed line.
I made
Okay.
a song.
I'm making it dashed because I don't want it to be confused with anything on the graph. Okay. It's dashed because it's going to be the only thing that's dashed. Okay. Everything else is solid lines. This is dashed though, so it's unique. Okay. So now we're reflecting it over this line. So that means if a point is one away from this line, it's going to be 1 away from the line on the other side now. Just similar to what we did with our axis of symmetry for our x-axis or y-axis on the previous couple. So L is currently how far away from this line? 1. So how far will it be away on the other side? 1. It'll be 1 away now. The new L will be 1 away. Okay? Did the y value change of that?
No.
No. So whenever we're changing something like this, is the y value changing? No. Okay, so we know our y values are the same. What values are changing then? If it's not the y values, it's the x values. Okay? So what is the new x value for L prime, our new L? What's our x value for our new L? We just grabbed it, it's
5
It's
negative 1.
5 comma negative 2. It's 5 comma negative 2.
That's what it's
Okay? We can think of it this way. How far is 3, the x value, away from 4, our line? How far is 3 away from 4? 1. So how far away from 4 do we have to be? 1. So what's 1 away from 4 on the other side? 5. Okay? If we look at
Can't see.
okay? Okay? Did you plot the L prime yet? L prime, L apostrophe? This is our new one. This is our old one, this is our new one. If we write L and L, we don't know which one's which. It's confusing. It's our line of reflection we have. We're reflecting over the line x equals 4. Okay, just like we reflected over the x-axis and y-axis earlier, now we're doing over x equals 4. Okay, which you said was a vertical line. Okay, how far is J away from this line x equals 4? 3. So how far away will it be on the other side? So what point will that be at? 7, comma negative 1. That doesn't change. The negative 1 doesn't change.
So it's just 4 plus the previous x.
That doesn't look
Okay.
right.
Doesn't look right.
Yes, it does.
When you put the K on
So how far away is the K away from that line?
2, 1.
It is 2 away.
What?
So how far away will this would be?
2.
2. So what's this value? It is 6, comma 3. So now we can connect those. And what happened was we just mirrored it over that line. We just reflected over that line. Okay? So, what ended up happening was our y values didn't change. Whenever reflected going this way, our y values didn't change. Only our x values did, okay? My hand's not changing height, okay? What's happening is my fingers are just changing left or right, okay? So our y values all stay the same. Our x values, well, how far was 3 away from 4? 1. How far is 5 away from 4? 1, okay? So if we go to point J, or point K, excuse me, how far is 2 away from 4? 2. How far is 6 away from 4? So that stays constant. How far is 1 away from 4? How far is 7 from 4? 3. So it still stays the same distance away from our line, okay? Before, that was just making it negative and positive, okay? Because that was dealing with a line of axis, a natural zero. But now we're not dealing with a natural zero. It's changing up a little bit, okay? Let's try number 6. It's pretty similar, okay? Number 6, square RSTU with versus RSTU. And we're reflecting on the line x equals -1. Okay, so let's first things first, we graph these points. R is 0, 3, so we'll go 0 left to right, 3 up. S is 5, 4. T is 6, -1. And U is 1, -2. Okay, and we're reflecting over the line x equals -1. Reflecting over the line x equals -1. So is that a vertical or horizontal line? Vertical or horizontal? It's vertical. I see I'll move his hands coming up. So make a dashed line at x equals 1. That's where everywhere where x is equal to -1, x is equal to -1, everywhere on that dashed line I just put. There's not a single place where it's not. So now, if we're reflecting over a line going this way, it means we're doing this with our hand, right? We're doing this with our hand. Please do this with me again. I know it's annoying, but please do it with me, okay? I did this back when I was a sophomore in high school, taking math class, okay? And it still sticks with me now. I'm saying it's effective, okay? So, are the y values or x values going to be changing? If we're reflecting this way, are the y values or x values changing? X values. So our y values are all going to be the same, aren't they? So can we go ahead and fill in our y values? I think it'd be wise to do that. So we can fill them in. 3, 4, -1, and -2. Now the x values are what's changing. So if you're more visually minded, we can do this one way. If you're just more numbers minded rather than visual, you're just more like facts minded versus numbers. I guess I don't know how to describe this. Images or non-images, I'm going to word it. Okay. If you're more images minded, it'd probably be a good idea to look at the graph and say how far away is it, and to keep going off of that. So if you're images minded, it might be better for you to plot the points first and say, oh, well this mirrors the R. And then plot the point and say, oh, well that's at -2. If you are not images minded, okay, put it away. If you're not images minded, it might be easier for you to say, hey, R is currently 1 away from this line. So what else is 1 away from -1? Well, -2 is. 5 is 6 away from -1. So we need to go 6 further away. Well, that'd be -7. Okay, once again, it might be easier for you to say, oh, well, S over here, then the S prime will be over here. Whatever is easier for you is what I want you to do, okay? Some of you, it's going to be easier to do the picture first and then to put the points. Some of you, it's going to be easier to put the points and then do the picture. Whichever one's easier, I want you to do, okay? So then T ends up being 7 away, so it has to be 7 away the other direction, -8. U is 2 away, and so it'll be 2 away, -3. And you might not know what you like right away, okay? So I would encourage you to try both. To try kind of a mixture of both. Sometimes try doing the graph first, sometimes try doing the numbers first, okay? And just see which one's easier for you, okay? See which one's more natural for you. I would encourage you to try both and just see which one's more natural. Okay? Until you find something that you like more. Okay? Questions on that? Okay. Mine's calibration is off, so I gave up using my straight edge. But that's what I use with pencil and paper. I do use a straight edge still. Not quite. We have a couple more examples we need to do. Okay.
I know.
So we're gonna skip 7 and 8 for now though, and I'm gonna hop into number 9. Right? Okay. So we need to see how these work. Okay. So on number 9 here, we're doing a triangle, and what are we reflecting over this time? Y equals x. We haven't done that yet. Okay. That's why we're learning this. Okay. That's why we're doing this one as well. So let's first plot like we do every time. So -5 comma -2 be over here for our x. Our y will be -3 comma 4. And our z is -1 comma 1. Okay. I'm going to go and connect that triangle. Okay. Now our axis, or excuse me, our line of symmetry, keep calling it axis, our line of symmetry, okay, will be y equals x. So y equals x, if we remember from algebra, is that line.
Why is that a thing? And why are you just visiting like 8 squares? You just have clumps of squares.
Oh, like here?
Yeah.
It just didn't copy well. I'm gonna have it on mine just like you have on yours.
Wait,
Just
so
didn't
if
copy
it was x equals y, would it be the
well. No, actually, y equals x and x equals y. That's the same equation. If it was negative x, though, it'd be the other way.
How do you?
Did we learn this?
I don't think we did, but sure.
I'm pretty sure.
That's just a normal linear equation. That's with nothing done to it. That's what a linear equation looks like. Then when you start doing this change of slope, a change in y-intercept, that's when it changes. But right now, nothing changed. It's just a normal linear equation. This goes through the origin, and when y is 1, x is 1. When y is 2, x is 2, so on and so forth.
So do we have to switch both?
Okay. So what we have to do here, what we end up doing, guys, to reflect it over this, is you have to take this and just kind of fold it over. It's kind of weird how it works, okay? So what we end up doing, is we end up taking our x and y. We end up taking our x and y. And what do you think, Graydon?
Switching.
We switch them. X comma y yields y comma x. We take where x and y are and we switch them. So let's take this x and y and let's switch them. So instead of -5 comma -2, x prime will be now -2 comma -5. Y, instead of being -3 comma 4, will be 4 comma -3. The y prime will. And z was -1 comma 1, so the z prime will be 1 comma -1. So after you put those down, we can now graph them and plot those points. So we plot -2 comma -5.
Oh, it's so ugly.
You looking in a mirror? Yes. We'll have 4 comma -3.
That was rude.
It was.
I did it wrong too. Wait, but how did I get
And
it wrong?
z is 1 comma -1. Last two, unless there's none after us, you forget.
But if x was flipped, it'd be 5 too.
-5 comma -2.
I don't know why that one looks smaller than that
You've run
one, but
negative.
I don't read it.
Okay? And so that's what happens if you were to fold the paper right here. If you were to cut this out and fold it, you'd get that exact same thing.
It took a Sharpie.
Traced it.
Yeah. You're like shadow box traces kind of thing. That's what you get.
I'm pretty sure we did something that in like art and like.
Okay? And so what ends up happening is for when y equals x, we get this. X comma y yields y comma x. I encourage you to write that down as well. Okay? I think it's helpful to review that. I think it's a good thing to go back to. Okay? I think you'd be foolish not to write that down. So whenever you see y equals x, you just follow that rule. You flip the y and x. And that flips it over or that line of symmetry. Okay? Questions on that one? Okay. We have one more we have to learn. This will be another pretty quick one. Excuse me. Over. Okay. So let's look at number 11 here. So we're going to graph these points. We have square A, B, C, D. So negative 1, comma 3 is A. Okay. Yeah, now y equals negative x. Good catch. Okay. B 0, comma 6. C is 3, comma 5. And D is 2, comma 2. Okay. So now y equals negative x. Instead of going uphill the whole time, it's not going to be going down. It's going to go the other direction. Very good job. And if you don't know how to graph that, guys, you can always start plugging in numbers, just like we did with graphing in Algebra 1 sometimes. You can plug in numbers. You can say, hey, what happens when I plug in 1 for x? Oh, you get negative 1. What was that?
I'm just gonna go opposite, so is it gonna be y x, but the x is negative?
Kind of. So we're going to go x comma y, and then just like we did with the other one when it was y equals x, we are going to flip them around, but now we have to do something extra. Because it's a negative, we have to make them both negative. So you flip them and make a negative. You flip them and make them both negative. When it's y equals negative x,
Wait, if both
you
are
flip 'em.
negative, do you just make a positive?
yeah. You take the negative, whatever's there. You take the opposite of what's there. So it's positive, negative, negative, positive. Alyssa? Okay, Carly?
What do you do with this negative y for the line?
Negative y equals negative x. So that'd be like just like the same thing as x, y equals x. Because that'd be like if you divide by negative 1, you get y equals x. Does that make sense? Okay. Question. Okay. So if we have negative 1, comma 3, who can tell me what that one would become for a prime?
Negative 3, comma 1.
Yeah, negative 3, comma positive 1. Okay, what would b become?
Negative 6, comma 0.
Negative 6, comma 0, because you can't make 0 negative, right? Or positive, neither. Okay, so c prime would be negative 5, comma negative 3, and then d would be negative 2, comma negative 2. And so you go ahead and plot those. So we end up getting, what would happen is it's just you flip it over that. Peyton,
Can you just count the boxes with
can you count the boxes away from the line? So if you go from like here, one up, one over, one up, one over. Yeah, I guess you could. If that's easy for you to think about, it should work. Okay. So once again, I encourage you to write this down here, a notation. I think that'd be helpful. I think it'd be very, very helpful for you guys to do. Okay. Okay, we have a short practice over this one. We have a short practice over this one. That's kind of nice. A little bit of a refresher, hopefully, for you guys to have a shorter one. I hope so.
So we're not starting to?
Nope. I said maybe. Yeah, we're not doing that.
He's really right. Really careful.
I put a question mark.
So
So technically no, but yes. Okay. I'd actually love it for you guys to put the rulers away back in that bin.
Whoa!
It's only half, it's only
Mr. Castle, what's wrong?
Oh my goodness, wait, there's not a bag.
Oh, I know. Easy job. No cap. No cap. Okay. So how many problems are there on here, guys?